Okay, we're in section 119 of the notes. As always, there'll be contents to look over, examples to do, and exercises that you really spend a lot of time on, or you should be spending time on. So my name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF that you're looking at here is being made available to the Prison Mathematics Project participants only. I realize that students and teachers may be watching these videos and interested in getting a copy. If you are, please email me and I'll update you about when it's going to get published and where you can get it. All right, I'm going to read through, and I want to point out a lot of this stuff, I'm going to say it's readable, I'll say that. But again, you may wonder where it's going. And certainly I'm going to do things the same way he does them, but also at times different the way he does those. So he kind of expands things out. That's a quadratic. This is a cubic, by the way, with known roots, by the way. You notice there's patterns over here. And I want to point out, the patterns of these things over here, and maybe I should point that out to you. Looking at this over here, it's related to this thing over here. All right, let me look at this one over here. This one over here is somehow related to this one over here. And I just keep going through that. I'm saying there's got to be some relationship, what he's talking about. This is a fourth degree one. I'll put this over here. All right, let me just underline this for you. This over here, somehow related to this one over here. All right, somehow related to it. By the way, I hope you see that relationship. It's kind of a simple relationship, all right? So, kind of looking at it, I'm starting to see that. I'm starting to see that, each time I'm seeing that last term, the product of the roots, and then this guy, the next term in, after the leading guy, which is x squared in this case, it would be a plus b related to that. After this thing, the next term, it's a plus b plus c is the coefficient. I get this over here. This one over here, this one over here. This is a nice simple pattern, by the way. A really nice simple pattern. So what I want to do is I'm going to say, he goes through it, talk about higher degrees, how those patterns emerge. What I want to do is I want to go to an example, and as I do it, he did it his way. I'm going to do it my way. All right, let me write this down for you. So 9x4 minus 37x squared minus 8x plus 20 is equal to 0. But they also say it can be factored, all right? So I want to get that down for you, but I know it's equal to 0, but he says he can factor it. And he says some of the zeros are this, x minus 2. He told me your root was 2. And the other one's going to be what? That would be what? That would be 3x plus 5, right? And I'm going to write this down over here, and this would be what? X minus, I have no idea. That's another root. And x minus b, that's another root. I got trouble right away. I'll tell you what the troubles are going to be. I'm looking at this thing over here, and I'm starting to realize I'm not going to get the 9. And why is that? I only have a 3. So I would get 3x4. So I'm going to need to put a 3 down here. The next thing I'm going to do, I'm not going to multiply that out, by the way. I'm going to let x equal 0. So I'm going to set x to be 0. And if you did that, what would you get? You would get 20 on the left side. And on the right side, be very careful here. You would get 3. You would get minus 2. You would get 5. You would get minus a. I don't know what a is, by the way. And you get minus b. Now this doesn't look that bad. It's 20. I'm going to try to resolve the sign there. It looks like you'd get, 30, minus 30. Whoops, that doesn't look like an a, does it? I got to start to make an erasure there. Not that it gives me much information. It gives me some information. I do know the product of those roots now is minus 2/3. And this is an important fact. And that's right over here. Let me point out where that is. So I'm glad I got that. Now, one thing I noticed about this over here is if you just did the product of the four roots, right? So what would the product of the four roots be? I'll write that down for you. Whoops. The product of the four roots, let's write this over here. So the roots are going to be 2. Let's see, the other root would be minus 5/3. And then the last two roots would be a and b. That's the product of the four roots, right? So let's see what you get over there. And I gotta do that now. What are you gonna get if you multiply that out? Well, AB, I know what AB is, right? It's minus 2/3. Let me write this down. So it's 2 minus 5/3. And then you're gonna get what? You're gonna get A times B, which is minus 2/3, right? And again, we'll talk about what this equals later. What do you get there? Let's see, 10/29. Right, I want to go back in the notes. I want to tell you what we're doing. I got to find it. We're doing this. You see that? What's it going to equal? This guy's coefficient. What is that guy's coefficient here? Well, if you recall, and I'll scroll back to it, there is no cubic term. So what are we getting? We're getting 0 for that coefficient over there. All right, so let me go back, make sure you understand what we're talking about. That guy's coefficient is 0. All right, so I know what A times B times C times D is, but now I'm going to look at this over here. A, B, C, D. All right, they're the four roots of the problem, by the way. How do I know that? It's written over here. So I'm going to write down all four roots, add them together. It's going to be the opposing sign. I'll write that down for you. And that's going to be, I'll write that down for you. So what's the A? Let's take a look at that. By the way, this is the four roots multiplied by 29, so I got that part covered. So let's take a look at that. I'm going to write this down. The A plus the B plus the C plus the D is equal to 0. And what are those roots? I have to remind myself. And what do you get over there? You would get, let's see, what would you get? You would get, what's A again? Oh, 2. What's the B again? Minus 5/3. Maybe I shouldn't say it that way because I have the A, B in the end. I should say C and D are those. And then I get the A plus B. Sorry about that. Well, let's see if we can do that. What do you get? Well, 2 plus minus 5/3. Let me write that down for you. That would be a 6, right? And then what do you get? You'd get 6. That would be 12. 7. Let me make sure I did that right. I'm sorry. Why am I saying 6? I'm sorry about that. I got to erase that. That's crazy talk. It's 3, isn't it? Sorry about that. I'm thinking 3 times 2 is 6. So let's see. 1/3. Plus A plus B equals 0. All right. Let's take a look what we got here. And I got to write it down. So A plus B equals minus 1/3. And A times B is minus 2/3. Boy, this looks just like the AC rule. So let's see if we can do that. And I'm looking at it, and I'm wondering how I can do that. I got to be careful here. I don't want to do a lot of work, by the way. I'm looking at that. See if I can get that. Let me think. Let me try a to be minus 2/3. And the b, no, I don't want to try that either. Let me try another one. Let me try a to be 2/3 and the b to be minus 1. Well, that does give me minus 2/3. And the question is 2/3 minus 1 minus 1/3? It is. So now I found the a and the b. All right. Let me go back up here and let me see if I can put that in now. All right. So let's go back over here. And I got to rework. I have to rework now. We'll look at the answer later. All right. So let's put this down. So I'm going to write this over here. So I'm now going to write down, we have to correct the coefficients again too. X minus 2, 3x plus 5, and I guess I have minus 1 and 2/3, right? Doesn't matter what I put them down. So I'm going to say x plus 1, and the other one is minus 2/3. So it's going to be, the other one would be x minus 2/3. Let me write that down for you. I'm going to write that as 3x minus 2. By the way, let me just say that this is equal to 9x4 minus 37x squared minus 8x plus 20. All right? Now, here's the deal. Does it equal that? Well, certainly I see the coefficient. I'd certainly check the first and last term at minimum. If you multiply this out, you would get 9x4. Let me just do the last guy, see if that's true too. You get the plus 20. Well, minus 2 times 5 is going to be minus 10. Times 1 is minus 10, times minus 2. Yeah, it works out pretty good. So I'm going to commit to this as an answer over here. You notice I'm not really multiplying it out. I do want to look at the answer, though. And, of course, when I'm looking at the answer, I want to make sure I'm getting the same answer over here. All right? And let's see if we did that. It's got that. X minus 2, 3x plus 5. Well, that's a no-brainer. 3x minus 2 and x plus 1. Yeah, we're getting it. All right? What's trouble here? I got to be honest with you. I would much prefer to use a long division. And let me just briefly go through that with you, all right? But the coefficients are nice, so that no patterns over there, it's really nice. If I were given this problem, and maybe I should write it down again. If I were given this problem over here, which is 9x4 minus 37x squared minus 8x plus 20, and I were told two of the factors, again, go back over here. What factors were you told? 2 and minus 5/3. So I'll write that down for you. And x plus, I'm sorry, I made a mistake there. 3x plus 5. I would put a question mark here saying there's something remaining over there. Again, I want to point out where these are coming from right in the beginning. They told me that. Coefficients, I'm not going to say I struggle with it, but it took me some time to work through that. Always possibility of making an error. What I would have done instead was I would have done a long division. And this is just me, by the way. This may not be everyone, but I do a long division. What would I divide through? This. I'm going to do that now for you. I'll show you get the same answer, by the way, probably a little bit quicker. So what are you going to get? 3x squared. And then you're going to get, let's see, that would be 3x squared. 5 minus 6 is minus x. And then what do you get? You get minus 10. Remember, the division is going to work out really nicely. I think I went on too far that division bar there too, didn't I? Well, what do you get? I'd say 3x squared. That would give you 9x4. We're going to get the same answer, don't worry. Minus 3x cubed. Let's see, minus 30x squared. Well, I got to subtract them. Things aren't lining up, but I can still do it. You're going to get 3x cubed. Let's see, minus 7x squared. Minus 8x plus 20. And again, if things are not working, I probably made a mistake somewhere. I'm going to say minus x. No, not minus x, plus x, right? It's going to be 3x cubed minus x squared minus 10x. Let's subtract. You get minus 6x squared plus 2x plus 20. And then I need to multiply by what? Minus 2, right? So it can be minus 6x squared plus 2x plus 20, which is 0. So I know the missing factor now. I'm going to erase this over here, which is quadratic. And what do you get over there? You would get 3x squared plus x minus 2. Now, by the way, what I'm saying over here is I'm hoping this is going to work out for you. And I'm looking at this over here, and that's a quadratic. And I can factor that quadratic. And let me write that down for you. You get x minus 2, 3x plus 5, 3x and x. Looks like 2 and 1. And let me just take a look at plus minus. Let me just make sure that's right. 3x squared, 3x minus 2xx. Yeah, it works beautifully. I got this over here. What I do is use long division. But again, I appreciate what Wells is saying. Now, of course, when I go back over, I want to make sure you understand we got that answer, x minus 2, 3x plus 5, and then 3x minus 2, and x plus 1. All right, let me just briefly go through the graph. As I go through the graph, I want to point out we're going to look at the factored form to do it. And I know the roots. One of the roots is at 2. And the other root's going to be, I'm just doing the easy ones first. So, one of the roots is 2. One of the roots is minus 1. I'm doing that here, and I'm doing that over there. The other root, 3x minus 2, would be 2/3, right? Well, this is 2/3. Let me write that down for you. X equals 2/3. That's a root. This is x equals 2. That's x equals 1. And let me do this one for you. What's it going to be? It's going to be minus 5/3. All right, that's x equals minus 5/3. The other thing I do is I put down the y-intercept, which is 20. That's very simple to do. And then I would do sign analysis. Now, when someone says, when you're doing sign analysis, is it going to be necessary? And it really is necessary to do sign analysis. And what I mean by that, if I put the numbers down, and I want to point out the numbers start at like minus 5/3. This is sign analysis. 1. I'm sorry, I said 1. It's minus 1. Minus 1. This is tough. I understand that. The other roots are going to be 2/3 and 2. Where are you plugging this in? I got to emphasize it to you. You're plugging it in here. All right? So let me just pull this on the side here. And I'm going to start plugging it in. Someone says, what are you plugging in? Test points. What's a good test point over here? Sorry about that. What's a good test point over here? 3. What do you get? First factor, positive. Second factor, positive. Third factor, positive. Fourth factor, positive. What do I know? It's positive function going up. All right, I want to pick another value between 2/3 and 2, and I'd pick 1. What would you get? First factor would be negative. Second factor is positive. Third factor is negative. Fourth factor is positive. Let me make sure I did this right. 1 minus 2 is minus 1, positive. Oh, I'm sorry. 3 times 1 is 3. 3 minus 2 is positive. By the way, someone says, why are you saying that? I saw the picture. I knew that couldn't have been the case. But it's negative over here. So I'm going to say whatever happens over here, and that's a 0 over here, you got to have a connection like this. All right, let's go between minus 1 and 2/3. A good test point over here is 0. Plug it in. What do you get? Negative, positive, negative, positive. What do you get over there? Well, overall it's positive. So let's say something like this over here. Hope you use. I'm just connecting together in a rather crude way. Okay, between minus 1 and minus 5/3, I'd say minus 4/3. Plug it in. What are you going to get? Negative. Oh boy, that's positive. Let's see what you get. Negative. And last but not least, that would be negative 2, right? That's negative. I get something like this over here. Okay, take a number after minus 5/3, like minus 2. Plug it in. Again, we're plugging it up here. What would you get? Negative. 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 And a negative. Boy, multiply together, positive. I want to just go back to the picture, by the way. And I want to point out, the picture is better than what I have, but it's got the same general shape. All right, same general shape. But I like this picture, all right? This is a good picture over here. All right, as we move through the course, by the way, we're going to be able to determine these points over here. This is a relative minimum. In other words, there's no point in the local neighborhood that's smaller than it, but it's also an absolute minimum. What does that mean? On the entire graph, that's the smallest point possible. What's over here? This is a relative minimum. It's not absolute because there's points below it. But in a neighborhood, he's the smallest guy. This over here is a relative maximum. Again, later in the course, Wells does briefly touch upon those points, by the way. And you can get those algebraically. Okay, so I'm going to say you got to get busy. And I know it's tough. This is all about coefficients, but there's other ways of doing it, including long division, which you just went through. Give me 1 second to undo that. So, exercise. What are you doing with the exercise? This one's super simple, by the way. It's a cubic. They give you 2 roots. Write it down. Pick a value for x that's easy. You'll get a very quickly. Before you proceed forward, though, I want to point out you definitely want to get this thing back in the end. So you really have to start thinking about it. It can't be this guy over here. It's this guy over here. All right? So that was easy. It's cubic. This over here, 4th degree. What do they give you? Oh, this is even another. They give you 3 of the roots. So it's going to be really easy to determine what the a is in that problem over there. Granted, I realize I may be doing things that you find rather strange, like dividing by 4, the coefficient. You don't have to do that, by the way. But your answer should be the same. I don't care what you're doing. Your answer should be the same. This one over here, it's 5th degree. They give me 1, 2, 3, 4. There's only one missing root. That's fairly easy to do. All right, fairly easy to do. All right, this one over here, it's a 6th degree. They give me 1, 2, 3, 4. Fairly easy to do. There's only one missing factor, and that's written down for you. All right, so that's written down, and I go through the work on that one as well. All right, this one over here, cubic. They give me 1, more difficult. What do I mean by that? There's 2 missing roots. So this is going to be a game to play, trying to figure it out. I certainly would do it by long division, but I want to point out I do write down the work for the coefficients. All right? So let's take a look. 4th degree, they give me 2. Again, I would do it by long division, and the reason that the depressed equation would be quadratic, very easy to deal with, but I do talk through the coefficient problem. All right, this one over here, 5th degree, they give me 1, 2, 3. Yep, the depressed equation will be quadratic. You could do it by long division or by coefficient matching. All right, I always find the coefficients to be rather difficult to do. This one over here, I don't have much choice on it. It's a 4th degree polynomial. He gives me 2. Again, I write the work down there for you. It's not easy, but I put it down for you. And I think I might have done something like, yeah, it's really not that bad. Again, I'm doing what Wells does with coefficients, by the way. You can still do long division if you like. Sage, whoops, sorry about that. What's Sage? Computer algebra system, CAS for short. It's open source. Go to this website. Either download it or use the interactive web-based application, and you'll see a lot of things over here for you if you want to get through. Again, my intent here is not to go through Sage, but to get you guys to work the problems as Wells want you to do that. And my email address, in case you see any errors, this is my email address. That's B as in boy, the @ symbol. That's a U, by the way. The @ symbol, nnon.us. Email me. What do you email about? You know what? Let's say you're working these problems, you think I made an error. Let me know that. I'll make a correction. And if I do, if there is an error, I'll correct it. All right? I'll give you credit for it, too. Thank you for paying attention.